An air purifier can lower the particle reading beside it and still leave the main problem untouched. That is not always a broken machine. Sometimes it is the wrong job, the wrong room, or a source that never stopped. To understand why, separate indoor air quality into 3 different jobs. The first job is source control. Stop or reduce whatever is adding pollution to the room. The second job is ventilation. Replace indoor air with appropriate outdoor air, or use local exhaust to carry pollution out where that is the correct strategy. The third job is filtration. Move air through media that captures a particular kind of pollutant. Those jobs can support one another, but one cannot replace another. The Environmental Protection Agency says the most effective ways to improve indoor air are to reduce or remove pollutant sources and ventilate with clean outdoor air. Filtration can be an effective supplement. That word, supplement, matters. A portable purifier is usually a room appliance. A fan draws nearby air through one or more filters and returns treated air to the space. A particle filter may capture airborne dust, pollen, smoke particles, and other particles within its tested range. A gas filter uses different media and depends on the particular gas, the amount of media, and the device design. No air cleaner removes every pollutant. A machine can therefore be working correctly while the thing you care about is outside its job. Here's the first mismatch. The source is still active. Imagine cooking smoke entering a kitchen faster than a small purifier can process the connected space, or moisture keeps entering a wall cavity while a purifier collects some particles in the room. The device may reduce part of what is airborne, but it does not stop the pan from producing smoke, repair the leak, dry the material, or correct the ventilation path. This distinction is especially important with recurring mold and moisture. EPA guidance says portable air cleaners and HVAC filters may remove some particles generated by mold, but they do not resolve a mold and moisture problem. The moisture source and appropriate cleanup still have to be addressed. That is not permission to identify mold from a picture, disturb a large affected area, or diagnose a health effect. It is a systems lesson. Filtering what reaches the air is different from stopping why it keeps reaching the air. The second mismatch is the pollutant type. Particle filters and gas removal filters perform different jobs. Clean air delivery rate, usually shortened to CADR, is a particle cleaning measure. It does not tell you that a device removes every gas or odor. EPA guidance notes that gas removal requires a filter designed for gases, often using activated carbon or other specific media, and there is no widely used performance rating for portable gas removal comparable to particle CADR. So a high particle score is not a universal clean air score, and a purifier is not a carbon monoxide alarm, a smoke alarm, a radon test, or a diagnosis of combustion equipment. A normal-looking consumer display does not prove that a room is safe. Those hazards have their own alarms, tests, emergency instructions, and qualified inspection methods. The third mismatch is room size. For particle removal, EPA guidance says the purifier's CADR should be large enough for the room or area where it will operate. The basic relationship is simple. A larger room needs more clean air delivered each minute. The common sizing charts assume conditions such as an 8-foot ceiling. A high ceiling adds air volume. An open doorway can connect the machine to a much larger area. A purifier selected for a closed bedroom may not perform the same way in an open-plan living room. This is why the number printed on a box needs context. Measure the actual area. Notice the ceiling height. Decide whether the space is really one room or several connected zones. Then compare the particle CADR under the speed you can realistically use. That last detail leads to the fourth mismatch, operation. Generally, higher fan speeds and longer runtimes filter more air. But the highest advertised performance is often measured at the highest speed. If the machine is too noisy and spends most of the day on its quietest setting, its effective cleaning rate will be lower. Placement matters too. The purifier needs room to pull air in and discharge it without being buried behind furniture, pressed against a curtain, or trapped in a corner contrary to its instructions. Closing a door may help when appropriately sized units serve one room. Opening the plan changes the job. The fifth mismatch is maintenance. Every filter loads with what it captures. EPA guidance is direct. Filters need regular replacement, and a dirty, overloaded filter will not work well. There is no honest universal replacement date because loading depends on the filter, fan use, pollutant level, and home. The correct interval comes from the device instructions and the filter's actual condition. Now add one more boundary. Avoid devices that intentionally generate ozone in occupied spaces. EPA describes ozone as a lung irritant and specifically advises avoiding portable air cleaners and HVAC filters that intentionally produce it. An energy efficiency label or a dramatic marketing name is not a health endorsement. With all of that, the practical decision is not which purifier should everyone buy. It is a sequence of questions. First, what problem are you actually trying to reduce? Particles, a gas, moisture, combustion, outdoor smoke entering the home, or something else? Second, can the source be removed, reduced, repaired, or exhausted safely? Third, is clean outdoor air ventilation appropriate right now, considering outdoor conditions and the home system? Fourth, if filtration is useful, does the filter target the right pollutant? And is its particle CADR large enough for the real room? Fifth, can the machine run at a useful speed, in a useful position, for enough time with the filter maintained? And finally, is there a separate alarm, test, or qualified inspection that this problem requires? This sequence does not make portable air cleaners unimportant. It puts them in the right place. A well-chosen purifier can be a valuable part of an indoor air plan. It simply cannot replace the other parts of the plan. The clue to the next problem is moisture. A room can look clean while its humidity makes condensation and recurring dampness more likely. In the next episode, we will examine what an indoor humidity reading actually changes and what it does not tell you.